Welcome back, dear students. This is Ravana Sir Physics. How are you all? We are discussing long answer type questions in intermediate second year physics. In that, already in the last classes we discussed waves chapter LAQs, and next most important LAQ is nuclear reactor. Here, out of 10 years, the last 10 years, if you observe, nearly 8 times this question will be there in question paper. That much important this question, that is nuclear reactor. They will ask question, explain the principle and working of nuclear reactor with help of neat diagram, and additional one attachment problem also they can ask. So that is why I'll discuss along with the help of neat diagram. In question only they'll mention with the help of neat diagram explain the nuclear reactor, and attachment problem also they can ask. After completing this, I'll explain the numericals also, problems also I'll explain. So first of all, we'll discuss what is nuclear reactor. The nuclear reactor is used to produce large amount of nuclear power, nuclear energy through controlled nuclear fission reactions. What is fission reaction? Here, controlled fission reaction we are saying. What is fission reaction? We know that the heavier mass of the nucleus, so whenever we are bombarding with the help of slow motion neutrons, what happens? It splits into two fragments and releases the large amount of energy. So that process only called nuclear fission reaction. So in that nuclear fission reactions, here in nuclear core takes place. Nuclear reactor mainly consists of 5 parts. Nuclear reactor consists mainly 5 parts. The first part is nuclear fuel. So these are the nuclear fuels. Okay, so nuclear fuels are sealed in aluminum cylinders. Nuclear fuels are sealed in aluminum cylinders. Here nuclear fuel. Nuclear fuel means the fissionable material used in the reactor called nuclear fuel. The fissionable material used in the reactor is called nuclear fuel. So generally as a nuclear fuel, so we can use uranium 235 or uranium 238 or plutonium or thorium, etc. As a nuclear fuels, we can use uranium 235, 92, 235 or 238, or plutonium or thorium we can use. The fissionable material used in the reactor called nuclear fuels. These nuclear fuels are sealed in aluminum cylinders. Aluminum cylinders. These aluminum cylinders are placed between the moderators. The second essential part is moderator. Second essential part is what? Moderator. Here the moderators. So here from after nuclear fission reaction, what happened? We are introducing one slow motion neutron. After nuclear fission process, what happened? So after splitting into two fragments, so large amount of energy releases, and again more neutrons also releases. So that neutrons may be fast moving neutrons. So that is why, so these neutrons are while passing through the moderators, what happened? So they slow down their fastness and continue the chain reaction. Why? Because for this nuclear fission reactions we need thermal neutrons, means slow motion neutrons. After one nuclear fission process, so the releasing neutrons may be fast moving neutrons. While passing through the moderators, what happens? Slow down their speed, become slow down and continue the further chain reaction. So that are called moderators. As a moderators we can use as carbon blacks or hydrocarbon plastics or heavy water, so we can use, or beryllium blocks also we can use. Here beryllium blocks or carbon blocks, beryllium or carbon blocks or hydrocarbon plastics, heavy water also we can use. Heavy water also we can use as a moderators. Next, here control rods. Here to Here nuclear fusion process is what? A nuclear reactor, what we discuss, controlled fission reaction means here averagely 3 neutrons are releasing. Okay, so here excess neutrons are absorbed by the control rods. These are the control rods made up by boron or cadmium blocks. So whenever these control rods are okay move up and down like that. So what happens that time? So moving up and down time, the excess neutrons are absorbed by the control rods and chain reaction can continue. If you want to stop the chain reaction, so what to do? If you want to stop the reactions, what to do? These control rods are completely inserted into the core. What happened? All neutrons are absorbed by the control rods and there is no further reaction. Chain reaction can comes to halt. Okay, so this reaction can comes to rest. Here controller's main duty is what? Main aim is what? To absorb the excess neutrons and control the chain reaction. As a moderators generally, as a controller generally will use as a controllers generally will use as cadmium or boron blocks. Cadmium or boron blocks will use. And next, here protective shielding. We are discussing, we know that in one fission reaction, averagely 200 million electron volt energy will be released. Here, the number of fission reactions takes place inside the core, reactor core. So that time large amount of energy releases. If any leakage is there, so what happens that time? So that is harmful for the operating persons. So that is why these surrounding by, okay, so it is made up by concrete blocks or lead blocks. Nearly thickness is 10 meters of thickness. 10, so that is called protective shielding or radiation shielding. Protective shielding or radiation shielding. So it is made up by concrete or lead blocks. So nearly thickness is how much? 10 meters of thickness. So concrete walls or lead blocks made up by this radiation shielding. So nearly 10 meters thickness. Why? Because so it gives a protection to operating persons. If any leakage is there, that is harmful for the operating persons. So that is why this radiation shielding or protective shielding made up by concrete or lead blocks. So with the 10 meters thickness. The last one, after releasing the large amount of energy, so that must move through the pipes. Here metallic pipes are there, so the pipes are arranged in some arrangement, so that is called coolant. The coolant consists liquid sodium or water. So while this large amount of heat passes through the coolant pipes, what happens? So these metallic pipes, so which are in coolant, so the surrounding liquid becomes hot and gives the steam. The steam is used to run the steam turbines. So this arrangement is called what? Coolant. The coolant consists liquid sodium or water. Here this coolant consists liquid sodium or water. Okay. So this while this large amount of heat passing through the pipes, what happens? The surrounding liquid becomes hot and steam is used to run the steam turbines. The steam turbines are connected to electric generators. So thus electric power will be released in the nuclear reactor. So these are the 5 essential parts. First one, what to write? Principle of nuclear reactor. So nuclear reactor is a device in this large amount of energy will be released. So through the controlled fission reactions. First principle you have to write. Then parts, the essential parts, there are 5 parts are there. Essential features, there are 5 parts are there. First one is what? Nuclear fuel. So nuclear fuel means these are the, okay, in this cylinders nuclear fuels are sealed. Like fissionable material used in the reactor is called what? Nuclear fuels. Fuels are sealed in aluminum cylinders. Fuels are sealed in aluminum cylinders. These aluminum cylinders are placed between the moderators. Moderators duty is what? Moderators are made up by beryllium or carbons or hydrocarbon plastics or heavy water. So this aim is what? Moderators aim to slow down the fast moving neutrons and continue the chain reaction. Next, control rods. These control rods move up, down, up, down. So why? Because so the excess neutrons are absorbed by the control rods. These control rods are made up by cadmium or boron blocks. Next, large amount of energy is releasing. If any leakage is there, harmful for the operating persons. So that is why here the surrounding walls are made up by the thickness of 10 meters, made up by concrete walls or lead blocks, and this large amount of energy we have to must remove through the pipes. The pipes are arranged in some coolant arrangement, that is called coolant. The coolant consists of liquid, sodium or water. Okay, here next, after this, what to write? Working you have to write. After this, working you have to write. So what to write? Working. So these matter only. The five features, about five features we discussed. About that five features, so what we discuss, points only you can write. Observe here how to write. Here, whenever slow motion neutron, one neutron is introduced in the reactor core, so what happens? These slow motion neutron, that is thermal neutron, okay, moves and hit the nuclear fuel, so like uranium or thorium or plutonium. So what happened? It splits into two fragments, averagely two fragments, and what happened? Large amount of energy releases and three neutrons also releases. That three neutrons may be fast moving neutrons. While passing through the moderators, what happened that time? So they become slowed down. The moderators are made up by beryllium or carbon blocks or heavy water or hydrocarbon plastics. Okay, here excess neutrons we need for controlled chain reaction. Previous generation and present generation, neutrons should be same. If excess neutrons are absorbed by control rods, okay, control rods are made up by boron or cadmium blocks. Okay, a large amount of energy is releasing in this, so we have to must use that one. Or if any leakage is there, what happens? Harmful for the operating persons. That is why the surrounding walls are made up by so concrete walls or lead blocks, thickness 10 meters. Why? Because it should be strong. Here next, this large amount of energy, this much large amount of energy while passing through the coolant, what happened that time? So the surrounding liquid, coolant consists liquid, sodium or water. So surrounding liquid, what happened? Become hot and gives the steam. The steam is used to run the steam turbines. That steam turbines are connected to electric generator, thus electricity will be produced. So thus working you have to write. After working, so this is a long answer. So uses also you have to write. What are the uses? First one, to produce electric power. First point is. The second one is what to write? In this nuclear reactor, so some radioisotopes also releases. That radioisotopes are used in various fields like medical field, agriculture field, industry field. Okay, so like radioisotopes are released in the reactor, so that are useful. So this is about the nuclear reactor. So based on this, the numericals also they can ask. I'll explain the numericals also, so you can check this. You can take first question. If 1 microgram of uranium 92-235 is completely destroyed in an atom bomb, how much energy will be released? In this, what they given in this problem? Nuclear reactor attachment problems, what they given? The mass is given. How much given? 1 microgram is given. 1 microgram they are saying. 1 microgram they are saying. Here 1 microgram we have to convert to kilograms. 1 microgram means what? 1 microgram. Here mu means what? 10 to the power of minus 6. And gram, 1 gram equal to how many kilograms? 10 to the power of minus 3 kilograms. Total how much? Mass m equal to 1 into 10 to the power of minus 9 kilograms. Here how much energy will be released? They are asking. Here the speed of light c equal to, we have to know, 3 into 10 to the power of 8 meter per second. How much energy released they are saying, they are asking. Here mass energy relation, Einstein Mass energy relation is what? E equal to mc square. From E equal to, what is the formula? mc square. Here E equal to, m is how much? 1 into 10 to the power of minus 9, and C 3 into 10 to the power of 8 whole square. Here E equal to 1 into 10 to the power of minus 9 into 3 square is 9, 10 to the power of 8 whole square is what? 16. 16 minus 9, how much? 10 to the power of 7. 9 into 1, 9 into 10 to the power of 16 minus 9, 7. 9 into 10 to the power of 7. Energy units are what? Joules. Here E equal to, what is the answer? 9 into 10 to the power of 7 joules. Sometimes instead of micrograms, milligram also they can ask. Once they asked milligram, here milligram means, milli means how much you have to take? 10 to the power of minus 3 we have to take. Instead of micro, they can give the milli. So that time what to do? 10 to the power of minus 3 you have to take here. Instead of gram, kilogram, 10 to the power of minus 3. Total how much? 1 into 10 to the power of minus 6 you'll get. This is one type of question. Another type question we'll see now. Take the second one. 200 million electron volt energy is released when one nucleus of uranium 235 undergoes fission. Find the number of fissions per second required for producing a power of 1 megawatt. In this problem, you can check here the given energy released in the reactor and power also they given. What they are asking, how many fissions occurred in this process they are asking. First given data will take. So here given the energy is given 200 million electron volt energy is given. Okay, that million electron volt energy I am converting into joules. How? Here m, so that is 10 power of 6, and electron volt, and electron volt is how much? 1 electron volt value 1.6 into 10 to the power of minus 19 joules. 1.6 into 10 to the power of minus 19 joules. Next, power is given 1 megawatt. 1 megawatt is given. That meaning is what? Mega means 10 to the power of 6. Okay, 6 watts. So number of fissions per second, n value or n by t, t value is 1 second only. T value is how much? 1 second per second they are asking. So n by t is how much they are asking. Okay, here from power, so the nuclear reactor power reactor formula is what? P equal to number of fissions into energy released per time. So how much time in how much time? P equal to Ne by T. Here N by T I am taking subject is equal to what? P by E. Substituting the values, P value is how much? 1 mega means 1 into 10 to the power of 6, and energy how much? 200 into 10 to the power of 6 into 1.6 into 10 to the power of minus 19. Here 10 power of 6, 10 power of 6 cancel. 1 decimal purpose, 1 0 cancel. Here 1 0 purpose, what happened? So 10 power of minus 19 become minus 18. So that time what happened? Remaining 2 16 ja 32 into what happened? This 10 power of 18 sent to numerator, 10 to the power of minus 18 sent to numerator plus 18. So that equal to, here from these two zeros I am taking by 32 into 10 to the power of 16. So cancel this one with 4 table or 8 table directly you can do. 8 4 ja 32, 8 1 ja 8 1 ja 8, more 2 is there, 8 1 ja 8, more 2 is there, 8 2 ja 8 2 ja 16, more 4 is there, what happened? 8 5 ja 40. With 4 table you cancel, 4 1 ja 4, 4 3 ja 12 decimal. Okay, so here 4 1 ja 4 and 4 2 ja 8 5. Therefore here n is how much? Here time is how much? 1 second only we are taking. N equal to 3.125 into 10 to the power of 16 atoms. 3.125 into 10 to the power of 16 atoms is the correct answer. Next one you can take. How much uranium 235 is consumed in a day in an atomic powerhouse operating at 400 megawatts, provided the whole mass uranium 235 is converted into energy? In this problem, Power is given 400 megawatts given, so that is 400 into 10 to the power of 6 watts, and time is given 1 day. So 1 day consists 86,400 seconds. Okay, here mass, how much mass is required they're asking. Before finding mass, so we have to know about the energy. Energy equal to power into time. Power equal to what? Energy by time. Energy equal to power into time. Substitute the values. Power is how much? 400 into 10 to the power of 6 into t value how much? 86,400 seconds. Okay, here energy value will get. So what they are asking, mass is how much they are asking. Mass is how much? From formula E equal to mc square formula, m equal to what? E by c square. M equal to E is how much? 400 into 10 to the power of 6 into 86,400 seconds divided by c square 3 into 10 to the power of 8 whole square. Solve this one, you will get 0.384 grams. Solve this one, you will get 0.384 grams. So these three questions chances are there for attachment problems. I hope all are understood this nuclear reactor answer very well. So if you like this video, please subscribe the channel and share to your friends. So very useful for both the TS and AP states. Most important question is in this nuclear lesson. Another question, radioactive decay law. The most important after nuclear reactor, chances are there nuclear radioactive decay law also. In this, how they'll ask question, what is radioactivity? State radioactive decay law and show that it is exponential in nature. They'll ask question like this. First of all, we have to define radioactivity means what. So we know that the alpha emission, gamma emission, beta emission. So the elements, heavier mass of the elements like more than 82 atomic number more than 82 elements. So for stability purpose, they emit alpha, beta, gamma rays spontaneously. This phenomenon is called what? Natural radioactivity or radioactivity. So radioactivity means you can say that the atomic numbers more than 82 elements spontaneously they emit alpha rays or beta rays or gamma rays. Okay, this phenomenon is called what? Radioactivity. Radioactive decay law means what? So the number of nuclei at certain time, the disintegration, the number of nuclei disintegration per time is directly proportional to the number of nuclei at that present instant. That the radioactive decay law means the rate of disintegration, that is dN by dt. The rate of disintegration dN by dt. That meaning is what? The number of atoms disintegration per second is directly proportional to the number of atoms at that instant. The meaning is dN by dt is directly proportional to the n according to the radioactive decay law. Here minus symbol we are taking. So why? Because as time passes in the graph you can observe. So graph on x-axis we are taking time, on y-axis the number of nuclei sample we are taking. At presently at instant t equal to 0 time, so the number of nuclei how much? N naught. As time passes, what happened after one half life you say? So what happened? This n become N naught by 2. And another half life, second half lifetime, what happened? N become N naught by 4. And another half life, third half lifetime, so that is N naught by 8. Like as time passes, the number of atoms in the nuclei is okay, so disintegrating or reducing. Okay, so here according to that formula, so that is why we are taking negative sign, we are taking minus dN by dt equal to n we are taking. Here proportionality symbol cancelling time, what to do? One constant will write minus dN by dt is equal to what? Lambda n. This lambda is called, where lambda is called what? Disintegration constant or decay constant. Here what I am doing, so this n I am bringing this side. So observe here dN by n, and this minus also I am writing this side, minus lambda into dt. Integrating on both the sides, I am taking integration on both the sides. Integration on both the sides taking. So that time what happened? Integration of dn by en is equal to what? Integration of minus lambda into dt. Here integration where to where? Initial the sample having n naught elements, so n naught to up to after certain time the sample having n. Here time initially 0, okay, after certain time, so the t, the integration limits here n naught to n I am taking, here 0 to t I am taking. Okay, integration of what I am taking, observe here, integration, okay, of n to n naught to n 1 by n dn, 1 by n dn is equal to minus lambda is constant, writing outside, 0 to t lambda t dt, 0 to t into dt. Here integration apply integration formulas. Integration of 1 by dx we know that, so that is log x. Here also like that only, log and integration of 1 by n dn is what? Log n to the base a. Limits are what? The lower limit is n naught, upper limit is n, is equal to minus lambda is constant, writing outside only. Integration of dt is what? T. Lower limit is 0, upper limit is what? T. Apply the integration limits, upper limit minus lower limit, log n, instead of n this upper limit I am writing log n to the base e, minus instead of this n lower limit I am writing log n naught to the base e, is equal to minus lambda, upper limit you write t, minus lower limit 0. Log a minus log b formula is what? Log a by b, log n to the log n by n naught to the base a is equal to minus lambda, t minus 0 is what? T only. Here the log form to exponential form I am writing. How? Here observe here, n by n naught is equal to this exponential going, so right hand side, so that whatever the constants are there goes as a powers. So n by n naught equal to this exponential is going here e power minus lambda t. Therefore n equal to what? N naught e power minus lambda t, n equal to n naught e power minus lambda t. So this is the radioactive decay law formula. So this integrate, so the number of nuclei exponentially decreasing, here exponential power minus is there, exponentially decreasing. So till here, so you have to write attachment problem also they'll ask. First what to write? Radioactivity definition, radioactive decay law statement, then explanation. In explanation time very simple formulas, okay, simple steps you have to write, okay, and you have to draw the diagram, and finally, so therefore the radioactive decay law, so is exponentially decreases in nature. You have to write one sentence. Then numericals, how they'll ask, we'll see on board. A question: the half-life of radium is 1600 years. How much time does 1 gram of radium takes to reduce 0.125 grams? In this first one, the half-life of radium is given. What they given? Half-life of radium T equal to what I am taking. So 1600 years given. 1600 years they given. So what they are asking? Half-life is given. Total time. Okay, how much time it will take to reduce 0.125 grams they are saying. Here 1 gram to full means what? 100% means, okay, 1 gram to 0.125 grams. 125 grams purpose, how many half-lives are there in this between? So we have to check. 1 gram to 1 by 2 gram, that is 0.5 grams. How many half-lives will take here? 1 half-life it is taking. Okay, 1 half-life it is taking 0.5 grams. Next, another half-life. So what happened that time? 1 by 4, that is 0.25. 0.25, that meaning is what? Another half-life, second half-life it is taking. Next 0.5 to 1 by 8. 1 by 8 means what? Here 0.125 gram means 3 half-life. So here 1 gram to 0.25125 grams means 1 by 8. That meaning is what? Total how many half-lives are there? 3 half-lives are there. So that equal to n equal to how many half-lives are there? Total 3 half-lives are there. So from formula, what is the formula? Small t equal to n into capital T. Total time equal to number of half-lives into half-life, each half-life. Substitute the values t equal to n is how much? 3 into 1600 years, that equal to 4800 years. Total time is how much? 4800 years. So next one you can take plutonium decays with a half-life of 24,000 years. If plutonium is stored for 72,000 years, what fraction it remains? Plutonium half-life is given how much? 24,000 years. That how much time they stored? 72,000 years they stored. So what amount, what fraction left they are asking. Here from this we know that first we will find the number of half-lives. From formula, small t equal to what? N into capital T. Here n equal to what? Small t by capital T. Small t is how much? 72,000 years by capital T is how much? 24,000 years. 72,000 years by 24,000 years. Here 3 zeros cancel. 24 1s are 24, 3s are. Therefore, how many half-lives are there? 3 half-lives are there. But they are asking fraction. Fraction formula is what? What is the fraction formula? N by n naught is equal to 1 by 2 whole power of n. Substitute n value 1 by 2 whole power of n. How much we got? 3 we got. 1 by 2 whole cube means what? 1 by 8. So mere remaining 1 by 8 fraction. So remains left. Next question. A certain substance decays to 1 by 32 of its initial activity in 25 days. Calculate its half-life. In this question the fraction is given. So how much given? Fraction n by n naught. Value is given. 1 by 32 is given. 1 by 32. That meaning 1 by 2 whole power of 5 we can write. N by n naught equal to 1 by 2 whole power of 5. Why? Because 32. So 2 into 2 into 2. So you can write. So 1 by 2 whole power of 5 you can write. You will get 1 by 32. That meaning is what? This formula is what? 1 by 2 whole power of n. N equal to how much? 5 half-lives are there. 5 half-lives are there. The total time also, stored time also they given. How many? 25 days they given. Total time. So how much they given? 25 days. Half-life is how much they are asking. We know that relation small t equal to what? N into capital T. Here capital T equal to what? Small t by n. Small t is how much? 25 by n is how much? 5. 5 1s are 5 5s are. Therefore t equal to how much? 5 days. T equal to how much? 5 days. So this is a problem for this. Next last one is there. So take that one. The half-life period of a radioactive substance is 20 days. What is the time taken for 7 by 8 of its original mass disintegrate? In this half-life is given, 20 days is given. So it remains how much left? They are saying 7 by 8 part means 1 minus 7 by 8, that is 1 by 8. The fraction n by n naught equal to what is the formula? 1 by 2 whole power of n. But here how much we got? 1 by 8 we got. 1 by 8 means what? 1 by 2 whole power of 3. Therefore n value how much we got? 3 we got. Here total time. From formula small t equal to what? N into capital T. Here small t equal to n is what? 3 into capital T is how much? 20. Therefore t equal to how much? 60 days. Therefore time t equal to how much we got? 60 days we got. Okay. So these are the radioactive decay law attachment problems. The radioactivity, radioactive decay law, explanation and this graph and these numericals equations like integration we have to apply in that. So these all we have to apply. Afterwards, attachment problem also they'll ask. If you write these all, you'll get 8 marks. I hope all are understood nuclear reactor and radioactive decay law. Already completed LAQs waves topics I have given in description. Another topics also, okay, I'll explain the current electricity also there. The topics also I'll explain in the next classes. Okay, I hope all are understood. Okay, if you understood, please subscribe the channel. Thank you for watching.